Hi students, welcome back to our online class. Today I am going to explain about radius of illumination, that is Snell's window, from the chapter Ray Optics. Right, the chapter name is Ray Optics, the topic name is radius of illumination or Snell's window. Right, we know that electric bulb is a source of light, one of the source of light. Electric bulb is one of the source of light. Suppose which is kept inside the water like this. Right, this is water where the electric bulb is kept like this. Right, so this electric bulb emits light in all directions. Electric bulb is one of the source of light which is kept inside the water. It emits light in all direction, right? Okay, when the light is instant on the surface, at an angle less than the critical angle, right? When the light from the source is instant on the surface at an angle less than the critical angle, What is critical angle? Right, see here. Suppose let us consider a refracting surface. Refracting surface means a surface which separates two media is known as refracting surface. So this is refracting surface. Why? Because it separates two media. Right. One of the medium is called rarer medium and another medium is called denser medium. Right. Which is rarer medium and which is denser medium? The light which travels or a medium in which the speed of light is less is called denser medium. The medium in which the speed of light is more is called rarer medium. Right? Comparing these two media, the medium in which the speed of light is less is called denser medium. The medium in which the speed of light is more is called rarer medium. Suppose this is rarer medium and this is denser medium. Right? Now a light ray travels in the denser medium and strikes on the surface, right? Suppose this is an angle of incidence. When the light travels from denser medium to rarer medium, the ray of light is bent away from the normal line. So this is normal line, right? This is normal line. This is incident ray which travels in the denser medium. It goes from denser medium to rarer medium. If light travels from denser medium to rarer medium, the ray of light is bent away from the normal. So this is incident ray, this is normal line. The angle between incident ray and the normal line is called angle of incidence. This is refracted ray and this is normal line. Angle between them is called angle of refraction. Angle of incidence and angle of refraction. Okay, already you are very familiar about this. Okay, when light travels from denser medium to rarer medium, the ray of light is bent away from the normal. In this case, angle of incidence is less than the angle of refraction. The angle of incidence is less than angle of refraction. Right. What happens if the angle of incidence of the light in the denser medium increases? If the angle of incidence of the light in the denser medium gradually increases, the angle of refraction value also increases. The angle of refraction value increases. At one particular angle of incidence of the light in the denser medium for which the refracted ray grazes the surface. The refracted ray grazes the surface. Right. That is, angle of refraction becomes 90 degree. Angle of refraction becomes 90 degree. If the angle of incidence of the light which is travels in the denser medium is gradually increases, the refracted ray is bent away from the normal. Okay. At one particular angle of incidence, the refracted ray grazes the surface of the surface of the two media. Right. Okay. So this angle of incidence is called critical angle. So critical angle means the angle of incidence of the light in the denser medium, the angle of incidence of the light in the denser medium for which angle of refraction becomes 90 degree is called critical angle. Critical angle. Right. Here, one of the ray of light from the source is strikes on the surface of the water, whose angle of incidence is suppose less than the critical angle. If the angle of incidence is less than the critical angle, the ray gets refracted and it emerges from the surface of the water. Right? If the angle of incidence of the light in the denser medium is incident on the surface of the liquid with an angle less than the critical angle, there is a refraction takes place, so the light emerges out from the surface. Right. Suppose one of the ray from the source is incident on the surface, its angle of incidence is greater than the critical angle. Here angle of incidence is less than the critical angle, so refraction takes place, so the light emerges out from the surface. But here angle of incidence of the light on the surface at an angle greater than the critical angle, there is no refraction takes place. Instead, the entire light reflected back in the same medium itself. This phenomenon is known as a total internal reflection. So angle of incidence of the light is beyond the critical angle, no refraction takes place. Instead, the entire light reflected in the denser medium itself. So that phenomenon is called total internal reflection. So here total internal reflection takes place when if the angle of incidence of the light on the surface of the liquid with an angle greater than the critical angle. Right. In third case, the light is incident on the surface at an angle equal to critical angle of the medium. Right. So in that case, there is a refraction takes place. That is, we can get a refracted ray. That refracted ray is grazes the surface of separation of the two media. Right. Now the angle of refraction is 90 degree. If the light incident on the surface at an angle less than the critical angle, the refracted ray emerges out from the surface of the liquid, that is water. If the angle of incidence of the light on the surface is greater than the critical angle, there is a total internal reflection takes place. If the angle of incidence of the light on the surface at an angle equal to critical angle of the medium, the refracted ray grazes the surface of separation of the two media. Right. So due to this, when we viewed this entire surface of the liquid, that is water, from outside, okay, the entire surface of the water appears illuminated. Illuminated means to shine light. That is, it glow brightly. Okay, due to the refraction and the total internal reflection, the entire surface of the liquid appears illuminated. Right, that is, it glow brightly if the surface of the liquid is viewed from outside. Right. Suppose on the other hand, the light entering the surface of the liquid from outside and which is seen from inside the water. Right. Here the light is coming from outside and entering the water, which is viewed from inside the water. Inside the water. Right. Okay. If the light is seen from inside the water, the view is restricted to a particular angle. Which is equal to the critical angle of the medium. Here the medium is water. Right. So when the light is entering the surface of the liquid from outside and which is viewed from inside the water, the view is restricted to a particular angle. That angle is equal to the critical angle of the medium. That is a critical angle of water. Right. Okay, here this restricted illuminated circular area is called Snell's window. Right? So this restricted illuminated, this area is illuminated when we viewed from outside. Okay, this restricted illuminated area is called Snell's window. Snell's window. Okay, are you clear? When the light is entering the surface of the liquid from outside, which is viewed from inside the water, the view is restricted to a particular angle. The view is restricted to a particular angle. Okay, in both sides or in all sides. Okay, so there is a circular area exists. That illuminated circular area or a restricted illuminated circular area is called Snell's window. Snell's window, right? Suppose let R be the radius of the Snell's window. The radius of the Snell's window, right? And small d be the depth of this point from the surface of the water. So R the radius of the Snell's window. And small d be the depth of the point from the surface of the liquid. Right. Here this radius of Snell's window or the radius of the restricted illuminated circular area depends on two factors. What are the two factors? One is depth. As the depth of this point increases, the radius of Snell's window, that is the radius of restricted illuminated circular area value also increases, right? And the second one, nature of the medium. Right? So the view is restricted to a particular angle which is equal to the critical angle of the medium. Okay, this restricted illuminated circular area is called Snell's window. The radius of the Snell's window depends on two factors. One is the depth from the surface of the liquid and the second one is the nature of the medium, that is refractive indices of the medium. Refractive index of the medium, right? So radius of the Snell's window depends on two factors. One is a depth and the second one is the nature of the medium. So what is meant by Snell's window? When the light entering the surface of the water from outside, which is seen from inside, the view is restricted to a particular angle which is equal to the critical angle of the medium. The view is restricted to a particular angle. That angle is equal to critical angle of the given medium, right? There is a circular illuminated area is obtained, okay, in this diagram. So that circular area is called Snell's window. Suppose let R be the radius of the Snell's window. This value depends on two factors. One is the depth and the second one is the nature of the medium, right? Okay, from a simple diagram we can derive an expression for the radius of a Snell's window. Right. Now let us deduce an expression for the radius of Snell's window. From this simple diagram we can derive the expression for a radius of Snell's window, right? Okay, see this diagram. In this diagram the ray of light is coming from rarer medium to denser medium. So suppose this is a rarer medium. Okay, one of the best example for rarer medium is air, because the speed of light is more only in air medium. That value is 3 into 10 power plus 8 meter second power minus 1. Already I told the medium in which speed of light is more is called rarer medium. Okay, one of the best example for rarer medium is air. Okay, because in this air medium the speed of light is 3 into 10 power plus 8 meter second power minus 1. So in this diagram the light is travels from air medium to, suppose it is water medium. Here let N1 be the refractive index of the water medium. What is the refractive index? the ratio of speed of light in air to the speed of light in medium is called refractive index of the medium, right? The refractive index of the medium is different for, refractive index value is different for different medium. So that is why the refractive index of water is taken as N1 and the refractive index of air is taken as N2. So N1 and N2 are the refractive indices of water and air medium, or denser medium and air medium. So rarer medium. Right. Here light travels from rarer medium to denser medium. Right. Here A be the point. From this point the light is seen, which is coming from outside, that is from rarer medium, right? And B is a point where refraction takes place. And R be the radius of Snell's window. And D is the depth of this point, that is the point A, from the surface of the water. N1, N2 are refractive indices of water and air medium. And B is a point where the refraction takes place. And A is a point, where the light is seen, which is coming from outside. And D is a depth of the point A from the surface of the liquid. And R be the radius of Snell's window. Right. From Snell's law of refraction, N1 into sine of angle of incidence, this is critical angle, N1 into sine I suffix C is equal to N2 into sine R, right? If the angle of incidence is equal to critical angle of the medium, the angle of refraction value is 90 degree. So or equal to 90 degree, because angle of incidence is equal to critical angle, right? Therefore N1 into sine I suffix C is equal to N2 into sine 90 degree, right? Sine 90 1. Therefore N1 into sine I suffix C is equal to N2, or sine I suffix C is equal to N2 divided by N1, right? Suppose this is taken as equation number 1. Right? From Snell's law of refraction, N1 into sine IC is equal to N2 into sine R. That is, R value is 90 degree. Sine 90 is 1. Therefore, N1 into sine IC is equal to N2. Therefore, sine IC is equal to N2 divided by N1. Right? In this diagram, just you consider this right angle triangle. That is A, B, C. This is like a right angle triangle. From the right angle triangle, ABC, so I suffix C be the critical angle, right? Sine IC is equal to, we know that sine is nothing but opposite side by hypotenuse, right? Opposite side BC, hypotenuse AB. Right, from the right angle triangle ABC, sine IC is equal to opposite side, that is BC divided by hypotenuse AB. So sine I suffix C is equal to BC divided by AB. Here BC is equal to the radius of Snell's window, that is R, right? Divided by AB value. Here opposite side is equal to R, adjacent side is D. Applying Pythagoras Theorem, we can get AB square is equal to BC square plus AC square. AB square we need, so AB square is equal to BC value R, so R square, and AC value is D, so D square. Therefore AB is equal to square root of R square plus D square. AB equal to square root of R square plus D square. Right, now sine IC is equal to BC value is R and AB value is equal to square root of R square plus D square. Right? Suppose this is equation number 2. Equation number 1, sin I suffix c is equal to n2 divided by n1. Second equation, sin IC is equal to r divided by square root of r square plus d square. Right? From equation number 1 and 2, from 1 and 2, n2 divided by n1 is equal to r divided by square root of r square plus d square. Right? And both the left hand side sin IC, sin I suffix c. So comparing these two equations, we can get n2 divided by n1 is equal to r divided by square root of r square plus d square. Right? Now squaring on both sides. Suppose this equation is taken as 3. Right? Squaring on both sides. Right? You can get n2 divided by n1 the whole square is equal to r square divided by r square plus d square. Okay, if the equation number 3 is squaring on both sides, we can get n2 divided by n1 whole square is equal to r square divided by square root of r square plus d square. Right. Okay, now taking reciprocal on both sides. For our convenience, this equation is taking reciprocal. Then this equation becomes n1 divided by n2 the whole square equal to r square plus d square divided by r square. R square plus d square divided by r square. Right? Or next step, r square plus d square divided by r square is equal to n1 square divided by n2 square. n1 divided by n2 the whole square or n1 square divided by n2 square. Right. Further simplification, 1 plus d square divided by r square. Okay, this term can be written as r square divided by r square plus d square divided by r square. R square cancels, so on. So 1 plus d square divided by r square is equal to n1 square divided by n2 square. n1 square divided by n2 square. Next, d square divided by r square is equal to n1 square divided by n2 square minus 1. Right? If the 1 is taken on the right hand side, positive becomes a negative. So d square divided by r square equal to n1 square divided by n2 square minus 1. Next, d square divided by r square is equal to n1 square minus n2 square divided by n2 square. D square divided by r square equal to n1 square minus n2 square divided by n2 square. Right? Now again taking reciprocal on both sides. Right? After taking reciprocal, this equation becomes r square divided by d square is equal to n2 square divided by n1 square minus n2 square. Okay, taking reciprocal on both sides of this equation, then this equation becomes r square divided by d square equal to n2 square divided by n1 square minus n2 square. Right? We need r, therefore r square is equal to d square of n2 square divided by n1 square minus n2 square. Right. Now taking square root on both sides. Square root. Okay, take the square root on both sides. R square becomes r and d square becomes a d and n2 square becomes n2 and n1 square minus n2 square becomes square root of n1 square minus n2 square. So this is an expression for the radius of a Snell's window or the radius of a restricted illuminated circular area. The radius of restricted illuminated circular area or radius of Snell's window is given by the expression r is equal to d of n2 divided by n1 square minus n2 square. Already I told the radius of Snell's window depends on two factors. One is depth. One is a depth. Second one is a nature of the medium. Nature of the medium. If the medium changes, automatically whose refractive index value also changes. So depending upon the value of refractive index of the medium and depth, the radius of Snell's window value changes. Right. Suppose if the second medium is air. Here second medium is air. For air, refractive index value is 1. For air medium, refractive index value is 1. Substitute N2 is equal to 1 in this equation. Then the radius of Snell's window equation becomes R is equal to D of N2 value 1 divided by square root of N1 square, or N1 is taken as N and N square minus 1. Right? If the rarer medium is air, then the radius of Snell's window or the radius of illumination is given by R is equal to D of 1 divided by square root of N square minus N square minus 1. Otherwise, the radius of Snell's window is R equal to D of N2 divided by N square root of N1 square minus N2 square. My dear students, Snell's window region over. Just you go through the topic. If you have any doubt, you call me or send message to my WhatsApp number. Thank you, student. We will see you in the next class.